the man who built one of the most important manufacturing companies in American history, never let anyone take his photograph. He constructed a one-room office on the roof of his own factory just to avoid being seen. He took the stairs instead of the elevator so he wouldn't get trapped in conversation. The thousands of workers who passed him in the hallway every day had no idea they were looking at the founder. He held 149 United States patents. His machines touched everything from the shirt on your back to the gears in your car to the temperature of the building you're sitting in right now. And in 1942, he was killed in a burning car crash on a rural Illinois highway, returning from a meeting about a wartime device that was never publicly identified. What he left behind changed the world. What happened to it after he died is the part nobody talks about. If you're the kind of viewer who digs into the machines and the people who built them, you're in the right place. This is Trade Archive. Hit like and subscribe so you don't miss the next one. William Alonzo Barber was born on January 11, 1843, in Galway, a small town in Saratoga County, New York. His father, the Reverend Bradford K. Barber, was a Baptist minister. The family relocated to Wisconsin in 1856, and young William spent his teenage years splitting time between country schoolhouses in winter and farm work the rest of the year. When the Civil War broke out, Barber was 21. On March 24, 1864, he enlisted as a private in Company B of the 37th Wisconsin Volunteer Infantry. His regiment shipped south and fought at Cold Harbor, one of the bloodiest engagements of the entire war. They pushed through the siege and capture of Petersburg, Virginia, and Barber himself participated in the final assault on Fort Mahone in April 1865. He survived all of it. He was discharged that July. After the war, Barber married Mary Lawton in 1867, settled in Warrens, Wisconsin, and pivoted into the lumber trade. He became a partner in the George Warren and Company lumber firm by 1875, and eventually its president. He served a term in the Wisconsin State Assembly in 1882 and was appointed postmaster of Warrens under President Grant. By the time he hit middle age, W.A. Barber was a respected businessman, a veteran, and a man with capital to invest. What he did not have was an inventor. That part came through his son Fred. Fred Barber had a boyhood friend named Howard Colman, born in 1873 somewhere in Wisconsin. The exact town has never been nailed down in the public record, and Colman himself never seemed interested in clearing it up. What is documented is that he never attended college. He taught himself the fundamentals of mechanics and physics from scratch, handcrafting his own earliest tools as a boy. The kid had an instinct for force and motion that no classroom could have given him. He could visualize a complete mechanical solution in his head before he ever picked up a pencil. By 17, Colman had built a wooden prototype of a machine that could automate part of the cotton weaving process. The problem was obvious. Wood doesn't cut steel. He needed iron and steel tooling, and he had no money. That's where Fred's father came in. In 1891, W.A. Barber examined the prototype and made a decision that would echo for the next century. He loaned 18-year-old Howard Colman $100. It was a modest sum, even then, and Colman never forgot it. When the company incorporated years later, he insisted that Barber's name come first. The return on that $100 loan would eventually be measured in the hundreds of millions. Colman relocated to Rockford, Illinois, and set up shop in an office above the Spengler Brothers machine shop in the city's water power district, right along the Rock River. His first commercially successful patent came in 1894 for a device called the creamery check pump, a mechanical system for separating buttermilk and measuring the flow of skimmed milk. It was a useful product for dairy operations, but it was not what Colman was really chasing. What he was chasing was the global textile industry. At the turn of the 20th century, weaving cotton was still brutally labor-intensive. When threads broke during the spooling process, workers had to stop the machine and tie the knots by hand. It was slow, inconsistent, and expensive. In 1900, Colman solved it. He invented the hand knotter, a small mechanical device that allowed a mill worker to tie weaver's knots quickly and uniformly. The patent, number 672,636, was granted on April 23, 1901. Demand was so immediate that Barber and Colman opened their own manufacturing plant in 1902 just to keep up. This is where the story takes a turn nobody expected. In 1904, Colman followed the hand knotter with something far bigger. The warp tying machine automated the painstaking process of threading warp yarn through the tiny eyes of heddles on a loom. Before this machine, that job was done entirely by human hands. After it, textile companies could reduce their workforce for that single operation by 86%. The patent, number 1,079,333, was granted in November 1913, though the machine had been in production since 1904. That same year, 1904, the operation officially incorporated as the Barber-Colman Company. By 1907, 5 major new buildings had gone up on the Rock Street complex along the river. Colman was 31 years old, and his machines were rewriting how cloth was made. He didn't stop there. In 1908, the company began manufacturing precision milling cutters for the metalworking trade. By 1910, they had introduced their first gear-hobbing machine. Gear-hobbing is a specialized machining process that uses a rotating cutting tool called a hob to carve teeth into steel gear blanks. The machines Barber-Colman built for this purpose, models like the 610 and the 1616, became legendary in the trade for their precision and their durability. Machine shop operators describe them the way car guys describe old muscle cars. They call them tanks. Some of those original machines, built in the 1920s and 1930s, are still cutting gears to specification in shops today, 100 years later. By 1927, Barber-Colman gear hobbers were running inside the massive Fiat automotive plant in Italy and at the Royal Typewriter Company factory outside Hartford, Connecticut. The textile division was expanding internationally, with branch facilities in Framingham, Massachusetts, Greenville, South Carolina, Munich, Germany, and Manchester, England. In 1919, they purchased the rights to the American warp drawing machine, and by 1921 they had added high-speed warpers and automatic spoolers to the product line. Barber-Colman didn't just compete in the textile machinery market, they owned it. And through all of it, the founder remained the ghost on the roof. Colman had no interest in being a public figure. He never gave interviews. He never attended industry banquets. When local newspapers tried to run features on Rockford's most successful industrialist, he refused to cooperate. According to accounts from the era, he wanted to be left alone with the work, and the work was all that mattered to him. A visitor to the Rock Street campus in the 1920s could walk the factory floor, watch hundreds of workers operating massive gear hobbers and textile machines, and never once encounter a photograph of the man who designed them. W. Barber didn't live to see the empire reach its peak. He died on February 16, 1913, at his home in Warrens, Wisconsin, the same year the warp tying machine patent was formally granted. He was 70 years old, but the company he had funded with that single $100 loan was just getting started. The Rock Street complex kept expanding. By the mid-1920s, more than 20 massive brick structures hugged the banks of the Rock River, connected by underground tunnels that let workers move between buildings without stepping outside in January. The campus had its own dedicated powerhouse. At shift change, thousands of Rockford citizens streamed through the iron gates. In 1914, Colman established an experimental department split into a chemistry lab for analyzing metals and a metallurgical lab for testing heat treatments. That same year, the company launched the Barber-Colman Continuation School, a 3-year paid apprenticeship program for boys 16 and older, run in partnership with the Rockford Vocational School. The company didn't just build machines, it trained the next generation of people who would build machines. In 1924, the electrical division launched with one of the most unusual products in the company's history, the Barcol Overdoor. It was a paneled wood garage door that opened on an overhead track, and the division's first prototype included a radio-operated electric opener controlled from the dashboard of a car. In the 1920s, that was science fiction for most homeowners. By 1929, the division had developed what it called cam-action hardware, a proprietary sealing system that closed the door 18 times tighter than a conventional wedge-type design. In the brutal Midwestern winters, that mattered. Meanwhile, in the experimental department, Colman's engineers had been developing temperature control instruments for commercial buildings. The work that started as internal lab experiments had grown into a full temperature control division by the late 1920s, manufacturing thermostats, pneumatic transmitters, and humidity control systems for large commercial structures. This detail seemed small at the time. It wasn't. This division would eventually become the most valuable piece of the entire company. The 1930s brought another unexpected chapter. While much of American industry was contracting during the Great Depression, Barber-Colman kept finding work. The Bakelite Corporation contracted the company to mold the cases for the TrueView stereoscope, an Art Deco-styled, three-dimensional film viewer that sold for $1 at drugstores and became a Depression-era consumer hit. The viewer used strips of 35mm film instead of individual cards, and the molded Bakelite housing had to be scratch-resistant and high-gloss to attract buyers. Barber-Colman's role was contract manufacturing, not product design, but it gave the company hands-on experience with a material that was about to reshape American industry. That plastics expertise would later evolve into an entirely separate business line, designing the electronic controllers that regulated temperature, pressure, and flow inside industrial plastic injection molding machines. A contract job molding dollar toys led, over time, to a controls division worth hundreds of millions. By the end of the 1930s, Barber-Colman had quietly diversified into textiles, machine tools, garage doors, temperature controls, and plastics. The company's competitors in any single category were larger and better known. Gleason and Fellows dominated the high end of gear cutting. Honeywell was the household name in thermostats. But none of them competed in all 5 categories at once. Barber-Colman's breadth was its armor. But before the company went to war, it went to court. And the case that followed exposed a side of Barber-Colman that didn't fit the humble inventor narrative. By the early 1940s, Barber-Colman held a process patent on a method for grinding hobs, the cutting tools used in gear-hobbing machines. The hobs themselves were unpatented. Anyone could make one. But Barber-Colman's licensing agreements included a clause that banned licensees from selling their finished hobs below Barber-Colman's established prices. The company was using a patent on a machine process to fix the price of an unpatented product. National Tool Company challenged the practice. The case, Barber-Colman Company versus National Tool Company, went before the Sixth Circuit Court of Appeals in 1943. The court's opinion noted that Barber-Colman's own operations accounted for roughly 1/3 of all hobs ground in the United States, not counting what its licensees produced. The judges ruled against Barber-Colman, holding that a patentee cannot use a process patent to create a monopoly on unpatented goods. The decision became a frequently cited precedent in American antitrust law, sitting alongside landmark Supreme Court rulings on patent misuse. You'd think someone would have raised the alarm about the price fixing earlier. Nobody did. Then, the world went to war. And the single most famous product in Barber-Colman's history was born out of pure military paranoia. Barber-Colman's expertise in miniature electrical devices and precision controls made the company a natural fit for wartime production. The company transitioned into manufacturing electromechanical and pneumatic valves for military aircraft, and its experimental department, which had been running chemistry and metallurgy labs since 1914, was suddenly working on problems with life-or-death consequences. The most urgent problem came from the United States Army Air Corps. Officials were terrified of a specific sabotage scenario. What if covert operatives infiltrated aircraft factories and swapped the high-strength aluminum rivets holding planes together with softer, inferior alloys? The aircraft would look perfect on the ground. They would rip apart in flight. The military needed a way to test rivet hardness instantly, on the spot, without destroying the rivet, and without hauling a 3-ton Brunel or Rockwell testing rig onto the factory floor. Howard Colman's son, Walter McGuire Colman, born May 12, 1903, engineered the solution. He designed the Barcol Impressor, a handheld, spring-loaded device featuring a hardened steel indentor shaped as a truncated cone with a 26-degree angle and a flat tip just 0.06 of an inch in diameter. An inspector could simply press the device against a rivet and read the hardness on a scale from 0, meaning full penetration and soft material, to 100, meaning no penetration and hard material. It was portable, it was fast, it was non-destructive. A single person could test dozens of rivets in the time it used to take to set up one conventional bench test. That invention outlived the war, the company, and the century. The Barcol hardness scale is still a globally recognized standard today, governed by ASTM D2583 for rigid plastics and fiberglass, and ASTM B648 for aluminum alloys. The same basic device was later used to perform hardness testing on repairs to the space shuttle. If you work in aerospace, composite manufacturing, marine boat building, or any field where you need to know whether a cured resin will hold under stress, you know what a Barcol reading is. Howard Colman himself did not live to see the full impact of his son's invention. On Thursday, June 25, 1942, Colman was driving alone on the Burlington Blacktop Road between Burlington and St. Charles, Illinois, reportedly returning from a conference on a closely guarded wartime device he had been developing. The nature of the device was never disclosed. A truck carrying baling wire with full 30-gallon gasoline tanks strapped to its running boards struck his car as it pulled onto the state highway. Both vehicles burst into flames. Colman's skull was crushed on impact. He was 69 years old. He had been married to Bertha McGuire Colman since the early 1900s, and together they had 4 children, sons Walter and Edwin, and daughters Ruth and Dorothy. One of the truck drivers, Harold Robinson of Joplin, Missouri, died of burns the following morning. Colman was taken back to Rockford and buried at Greenwood Cemetery. The man who held 149 United States patents, who had essentially automated the global cotton industry and built a multinational industrial empire from nothing, was mourned by a workforce that largely could not have picked him out of a photograph. Harry Severson, one of the company's 3 original directors, took over leadership. But Howard Colman's DNA was already embedded in the company too deeply to be removed by his absence. The post-war decades were the peak. In 1953, the company built its Park plant, a modern 125,000-square-foot facility on Clifton Avenue in Loves Park, Illinois, just north of Rockford. By 1965, 3 major additions had expanded it further. A second facility of 200,000 square feet went up next door in 1968. Barber-Colman was running out of room to grow. The Barcol Overdoor division, meanwhile, was having its own golden era out of a dedicated plant in Sheffield, Illinois, about 90 miles southwest of Rockford. By 1964, the division employed 150 workers, generated over $4 million in annual sales, and was exporting its premium garage doors throughout Europe and South America. Their competitors in the trade association, companies like Crawford Door, Overhead Door, and Wayne Dalton, knew the cam action hardware made a genuinely superior product. The problem was the price tag. When the steel door market exploded in the 1970s with cheaper, mass-produced panels, Barcol was late to pivot. A recession in 1983 hammered their commercial business by 25 to 30%. The division was sold off to the R.C. Mahon Company in 1967, then passed to Plycraft, and ultimately shut down around 1990. A company that had literally invented the automatic garage door opener in 1924 couldn't survive the market it created. The HVAC controls division had no such problem. It just kept growing. By the late 1970s, the industry recognized Barber-Colman as one of the big five commercial controls manufacturers in the world, alongside Honeywell, Johnson Controls, Powers, and Robert Shaw. Their pneumatic thermostats and transmitters regulated the climate in office buildings and hospitals across North America. The company's Mako line of compact process controllers, which managed temperature and pressure inside industrial injection molding machines, added yet another revenue stream. Barber-Colman had become a company that was nearly impossible to categorize. Textiles, machine tools, HVAC controls, plastics, aerospace, garage doors, all under one roof. In 1954, they acquired the Hyundai Machine Company to bolster their metalworking portfolio even further. By 1975, at the absolute zenith, the company employed over 4,000 workers spread across 150 locations worldwide. It was still privately held, still family-run, still answering to nobody. But peak power came with a cost the balance sheets didn't show. The massive textile and milling machines that built the company's fortune were dangerous to operate. Workers on the factory floor spent their shifts alongside unguarded nip points, high-speed rotating cutters, and cast-iron mechanisms that could crush a hand in a fraction of a second. Lawsuits like Barnwell versus Barber-Colman Company in 1992, which documented severe injuries from a worker's hand being caught in a machine, were part of the grimmer reality of heavy manufacturing in the decades before modern OSHA standards mandated comprehensive machine guarding. If Howard Colman had stopped here, this would be a very different story. But the company was built around a single family, and families are fragile. On November 9, 1983, Walter Colman died. He was 80 years old. He had run the company for 4 decades after his father's death, keeping it private, keeping it family-owned, keeping it independent. There was no succession plan. There was no next generation of Colmans ready to step in. The board made the decision to break the company apart. The dissolution was methodical, and it happened fast. In 1984, the textile division, the original business that had started everything back in that office above the Spengler Brothers machine shop, went to Reed Chatwood Incorporated. Reed Chatwood continued manufacturing at the Rock Street complex, but the American textile industry was already hollowing out as production moved overseas. Reed Chatwood slowly contracted over the next decade and a half before shutting its doors entirely around 2001, leaving the historic campus completely vacant. In 1985, the machine tool division, home to the legendary gear-hobbers that had been running in factories from Connecticut to Italy, was sold to Bourne & Koch, a fellow Rockford company that still makes OEM parts for Barber-Colman machines today. With that sale, Barber-Colman's local employment dropped from roughly 4,000 to about 2,200. The clock was ticking, and Rockford could hear it. Then came the crown jewel. In 1987, the British engineering conglomerate CB plc bought the controls, HVAC, and plastics divisions, folding them alongside its recently acquired Robert Shaw brand. The purchase pushed CB's annual turnover past £1 billion. In 1999, CB merged with BTR to form Invensys. That same year, Invensys sold the aerospace division, which had been making aircraft environmental control systems out of the Loves Park plant, to London-based Smiths Industries. The French multinational Schneider Electric then purchased Invensys Building Systems in 2006, absorbing what was left of the Barber-Colman Controls architecture. Every single division ended up in somebody else's hands. Not one stayed independent. The $100 loan had generated an empire, and within 4 years of Walter Colman's death, that empire had been parceled out to British and French corporations an ocean away from the Rock River. When Reed Chatwood closed the Rock Street complex around 2001, nobody came to replace them. The city purchased the property for a few $100,000, far less than the cost of cleaning it up. A century of heavy manufacturing had left the soil toxic and the buildings full of asbestos. The monolithic brick factory sat fenced off and rotting on the banks of the Rock River for 20 years. In 2006, it was added to the National Register of Historic Places. That saved the buildings from demolition. It did not fix anything else. Eventually, a Milwaukee-based developer purchased the site and announced a $430 million plan to convert the historic campus into a mixed-use district called Colman Yards. Apartments, commercial space, maker studios. It was supposed to be Rockford's rebirth story. Instead, it became a political fight. A bitter dispute over union labor requirements split the city council, triggered protests, and ended with a subcontractor's trailer set on fire at the job site. By 2024, the general contractor had been fired, millions in mechanics liens had been filed against the property, and the project ground to a halt. As of early 2026, a new contractor has been hired and work has reportedly resumed, but the lawsuits remain unresolved. Through all of it, the mechanical legacy of Barber-Colman endures in places most people never look. Bourne & Koch still manufactures CNC gear hobbers based on the original Barber-Colman geometry, right there in Rockford. A small company called Crandall Stats and Sensors, founded in 2014 by a former Schneider engineer, continues to build Barber-Colman design pneumatic thermostats with about 30 employees. The Barcol Impressor is still manufactured and sold worldwide. And thousands of original Barber-Colman gear hobbers, some built before World War II, are still cutting gears to specification in machine shops on every continent. In 1987, Howard Colman's eldest daughter, Ruth Colman Tower, established the Howard D. Colman Memorial Scholarship through the Community Foundation of Northern Illinois. It was funded by a charitable remainder trust created from the proceeds of the company's sale. The first scholarships were awarded in 2011, and since then, the fund has given over $500,000 to engineering and technology students from the Rockford area, connecting them with internships at local manufacturing firms. Ruth wanted to ensure that her father's spirit of self-taught invention didn't die with the company name. The Barber-Colman Company no longer exists, but the machines, the standards, and the scholarship fund all do. And on Rock Street in Rockford, the brick walls of the factory where Howard Colman built his rooftop office are still standing, waiting to find out whether the next chapter is a revival or a demolition. That story isn't over. Not even close. If you want more stories like this, about the inventors, the machines, and the empires they built, subscribe to Trade Archive. And if you want to see how another company turned a single invention into a global industrial dynasty, click the video on screen now.